Hi y'all. So this is Mrs. Tran-Bloom. I am recording for this video. I'm recording how to graph and define cotangent inverse function. Okay. So the first thing we are going to start with is the basic parent function for y equals cotangent of x, and then we will try to answer some questions over here and come up with the restriction for the inverse function of cotangent. Looks like I kind of formatted this strangely. So what I'm going to do is make a table up here for input y equals cotangent of x. Okay. So the 5 inputs are 0, pi over 4, pi over 2, 3 pi over 4, all the way to pi. The outputs for cotangent are undefined at 0, 1, 0, -1, and undefined again at pi. We have a period of pi, so what I'm going to do is go a pi to the right and a pi to the left. I just want to show you 2 full cycles of this. Half of it is pi over 2. Okay, so 4 equal tick marks. This is a pi over 4. Similarly, we're going to do exactly the same thing to the left-hand side. Okay. I'm going to go up 1, so this is a mark of 1, so I don't need to label it. So the first input is 0. Right away, we have an asymptote, so I'm just going to put the marks right above and below the y-axis. At pi over 4, we have a mark at 0. At pi over 2, we have 0. At 3 pi over 4, we have an output at -1 and another asymptote here. So if you look at this, we have a pattern. We have an asymptote pi units apart, okay? So there's another asymptote. And repeat because it's periodic. So that means it goes the same way every period. Okay. You know, it's funny because I was grading some of the tests that you guys recently took, and when a few of you graphed this out, you went like this. Is that really what I'm looking for? Okay. No, I'm not looking for some creative graphs. I'm looking for some nice and smooth and continuous cotangent or tangent function here. This is particularly cotangent. So y equals cotangent of x is definitely not a 1-to-1 because it does not pass your horizontal line test. Because your answer is no, we have to restrict its domain so it can be a 1-to-1 function. 1-to-1 function. Okay? 1-to-1 function. So universally, we have gathered together mathematicians before you and I were born and said, hey, you know what? Let's just all agree on from here to here. Now, is it wrong to say it's from here to here? No, it's not wrong. But that's not what all of the mathematicians agreed upon. They have said, hey, you know what? We like to work with positive numbers better. So they've said, let's just agree that we're going to pick some restriction from 0 to pi. Okay? So that's our first page. We are now about to flip over so we can complete the second page of this. Again, I apologize for the weird formatting. Some spacing went wrong. Okay. Now we are going to define the inverse of cotangent. The inverse of cotangent is y equals, some book will write art cotangent of x. Your book is writing y equals cotangent inverse of x. Now these are only true, obviously, if and only if x equals to cotangent of y. Okay? Because when you're looking for the inverse function, you're switching your x and y. And when you're solving for y, this is what we come up with. So our next thing right here is we are going to sketch out a graph of the inverse. So to do that, I'm just going to show you what we have graphed earlier. Okay. So we are going to graph out from 0 to pi. We have 2 asymptotes, one at 0, one at pi. Its inverse, it's going to now have horizontal asymptotes. Let me move this over. So we are going to have the first horizontal asymptote is 0. The next one, let's call this pi. We are going to have a horizontal asymptote at pi. Okay. Looks like we have 3 dots. Okay. 3 dots right here. This first dot is pi over 2, I'm sorry, pi over 4 comma 1. So see this first dot right here? Pi over 4 comma 1. Its inverse is then 1 comma, let me make the marks here. If that's a pi, this is going to be I need 4 equal intervals. This is pi over 2. Okay, this is a pi over 4. So my original dot is pi over 4 comma 1. Its inverse is going to be 1 comma pi over 4. So there's my first dot, labeled it 1 comma pi over 4. Awesome. Right? Our next dot right here is pi over 2 comma 0. So its inverse is going to be 0 comma pi over 2. Label this dot as well. 0 comma pi over 2. Okay. My next dot is 3 pi over 4 comma negative 1, which is right here. 3 pi over 4 comma negative 1. So its inverse is we are switching x and y, so it's now negative 1 comma 3 pi over 4. So let's label this negative 1 comma 3 pi over 4. Okay. So kiss your asymptote. Come back down this way. Smooth and continuous. That is my inverse function for cotangent. Let's try to state the domain in the range. Okay. The domain of cotangent inverse, as you can tell, is going to be all real numbers. The range of cotangent inverse, as you can tell, is going to be from 0 to pi non-inclusive. Let's state the quadrants as well. Okay? Cotangent is restricted in 2 different places. In quad 1, because it is from 0 to pi. 0 to pi is here, so that's going to be quad 1 and quadrant number 2. Okay? So there are 3 different functions that are restricted in quads 1 and 2. Obviously, cotangent inverse is one of them. Cosine inverse is the other. And the last one is going to be secant inverse. Okay? Those are quad 1 and 2 restriction. Then obviously the 3 that I did not mention would be quad 1 and 4. This is the end of the video notes. Have a wonderful day.